In example A, we're finding absolute maximums and minimums of this function, and then they give you an interval. So we've got endpoints to the function. And so what we're going to do is find the derivative and set it equal to 0 and find our critical points first. So I've got a function. Let's find the derivative of it. I get 3x squared minus 6x and plus 0. And then I want to find the critical numbers, so I'm going to set that equal to 0. And then I'm going to factor out a 3 and an x. That would give me x minus 2. And then set each of these equal to 0. And we get critical points at 0 and at 2. And then if you look at your derivative, this is defined from negative infinity to infinity. So there's no asymptotes or anything that are going to give me another hidden critical point. And then we're looking for absolute maximums and minimums. So what we're going to do is we're going to take the original function and we're going to plug in our critical numbers and see what those are. And then we're also going to plug in our endpoints, whatever endpoints they give you, and see what their y values are. Whichever of these gives me the highest y value is your absolute maximum. Whichever of these gives you your lowest y value is going to be your absolute minimum. So when you go plug in 0, you get 1 in the original function. When you plug in 2 to the original function, you get negative 3. When you plug in negative 1/2 up here, you get 1/8. And when you plug in 4 up here, you get 17. So looking at these y values, my smallest one is my absolute minimum, which would be at 2. And then the largest one is your absolute maximum, which is at 4. And that is how you find your absolute maximums and minimums.